is equal to a times x minus p squared plus q graph also starts from y is equal to ax squared graph, but this graph is addition of this graph y is equal to ax squared plus q and a times x minus p squared graph. So for y is equal to a times x minus p squared plus q graph, we already know that a is a value that defines a graph's form, quadratic functions graph form, whether it goes upward or downward. And for x minus p squared plus q's graph means we use y is equal to ax squared graph as a basic format, and we transformed it to the y. We moved that graph to the x-axis direction for the p times, and we moved that transformation graph to the y-axis direction for the q times, and this is what this y is equal to a times x minus p squared plus q means. But in terms of properties of y is equal to a times x minus p squared plus q's graph. The first property of y is equal to a times x minus p squared plus q's graph is that it is a transformation of y is equal to ax squared graph, and it is a transformation to the x direction for p times and to the y-axis direction for q times. And this is a statement that we already learned in the up through our graphs, and this is what this graph means. This is what this thing means. Y is equal to a times x minus p squared plus q. And let's think about in terms of a second property of this function. So for a second properties of y is equal to a times x minus p squared plus q's graph, it is that it has a vertex of p comma q, and then x is equal to p is a axis of symmetry of this function. So the reason why it has vertex at p comma q is because we know that the basic format of the graph is y is equal to ax squared, and the y is equal to x squared graph is minimum or maximum point depends on the a value. It will going to be a origin as we have learned, which means it is 0, 0. And all we did is x value is 0 and the y value is also 0. And the reason why it has p comma q is because we moved into a p times to the x direction, which means the x value will gonna be changed according to how the distance for changed to the origin. And we don't know exact values, so we just put that into a p. But for this one, the y value is still 0, but we know that we moved this transformation for the q times to the y direction, but we don't know a value of its y direction exactly, so we just put that value into q. So p comma q, that's why it is a vertex of this function. And the reason why the x is equal to p is axis of symmetry is because we know that in order to find the axis of symmetry, the x values are the minimum and the maximum value should be a standard of axis of symmetry. The reason why we need to find the axis of symmetry of a times x minus p squared plus q's graph is because for the y is equal to ax squared graph, we know that the axis of symmetry is the case, which is the y-axis, but the standard of its axis of symmetry is the case when the x value, which makes this whole expression turn into 0. And so for this term right over here, if you make a dotted line, all you have to see is a value of the x, which turns this whole expression into 0. And we also know that this term will going to be a axis of new symmetry. And for the value of the x that makes this whole expression turn to 0 is a case when the x value is equal to p. P minus p turn to 0, and then this whole expression will turn to 0. So we can say that the axis of symmetry is the case when the x value is equal to p. And in order to find the axis of symmetry, all we have to see is that for that quadratic function, the x value, which makes this whole expression turn into 0. And if I give an example for this y is equal to a times x minus p squared plus q's graph. So before you think about our examples of for this function, let's think about in terms of this form of our quadratic function. For this quadratic function, y is equal to a times x minus p squared plus q. We call this as a vertex form. The reason why we call it as vertex form is that using this format we can find the function's vertex easily. The vertex of this function will going to be, we don't care about the a value. The vertex of this function will going to be x comma q. But we also need to remember is that if it's a negative p, we always should write opposite, which means when the p value is negative, x value should be positive, and when the p value is positive, the x value should be negative. And that's the case how we find the vertex of a function. So if you think about our first one, y is equal to x plus 4 squared plus 2. The vertex of this function, at first the p value is 4, which means the x value should be opposite of that, which will going to be negative 4. Then if we input a value of negative 4, this term will just cancel out as 0, and we get a y value, which is a constant, will going to be 2. So negative 4 comma 2 will going to be our vertex of our function according to our vertex form property. So if you graph it negative 4 comma 2, it will going to be right over here. And the coordinate is negative 4 comma 2, and this is our minimum point. So if we graph more points, we can actually find easy points to graph when the x value is negative 1. When the x value is negative 1, negative 1 plus 4 is positive 3 squared, then plus 2. 3 squared is 9 plus 2 will going to be 11. So we can actually derive that negative 1 and 11. I will just write an approximate value right over here. And let's think about it in terms of a case when the x value is negative 3. When the x value is negative 3, negative 3 plus 4 is positive 1. Square plus 2 will turn into 3. So we can actually graph that. It will going to be right over here. And let's think about in case when the x value is negative 5. When the x value is negative 5 right over here, it will going to be negative 1 squared plus 2, which will just turn into positive 3. So it will going to be right over here. So if we actually graph it, it will going to be something that look like this that passes through our points. So this is our quadratic function. And let's look at our other example. Y is equal to negative x plus 1 squared minus 3. And let's look at our vertex at first. But before I do that, we figure out the a value, which is negative, which means the graph will go downward. So our vertex of this function will going to be the p value is 1, which means the x value should always be opposite of it, which will going to be negative 1. And if we input a value of negative 1 into x value, this term will cancel out as 0, and we get an output of our y, which will turn into negative 3. So if we actually graph it, so I'll write our function here, y is equal to negative x plus 1 squared minus 3. We figure out our vertex negative 1 come negative 3, which will going to be right over here. And this will going to be our maximum point. And let's look at our other points to graph this function. At first, let's input our value of positive 2. if you input a value positive 2 plus 1 is positive 3, squared is 9, but there's minus, so we can write minus 9, and then we have minus 3, which will going to give us negative 12. So you will going to be approximately right over here. And let's think about in case of when the x value is 1. When the x value is 1, 1 plus 1 will turn into 2, and then minus, so minus 2, and then minus 3 will turn into negative 5. So we can actually graph that. It will going to be something that look like this if we graph it. And it will going to be approximate value because we don't have enough spaces for our coordinate plane. And we figure out two cases using our y is equal to 8 times x minus p squared plus q's graph. So we have learned about the 5 main graph of our quadratic function. And if I review it, y is equal to x squared graph. This graph passes through the origin and it always should be a minimum point right over here. The reason is because there is no a term, so since we input a value of a negative value into x value, it will going to square it, which will going to give us a output of positive value. And we need to remember that when the x value is greater than 0, the y value decreases as we have seen here. And when the x value is greater than 0, y value also increases. Let's think about it in terms of y is equal to ax squared graph. And y is equal to ax squared graph is the addition of the a, which defines the quadratic function's format, whether it goes upward or downward. And it was a basic format, it was an advanced format of y is equal to x squared graph. And we need to remember that the origin, which means 0, 0, can be either a minimum or a maximum point. Depends on our a's value sign. And we also need to remember that if a absolute value of a value is big, the width of the parabola will be small, like this case. And for y is equal to ax squared plus q, y is equal to ax squared, are same with this quadratic function, but all we did is we transformed it, which means we moved its quadratic function graph to the y-axis direction for the q times. And it will gonna have a vertex at 0, q as we have proved it. And also for y is equal to 8 times x minus p squared graph, we need to remember that it is a transformation of y is equal to ax squared graph, which we transformed it and we moved that quadratic function's graph for the p times to the x-axis direction. And it will have a vertex p, q, and its axis of symmetry is when x is equal to p. And in order to find the value of axis of symmetry, we also need to remember that it will going to be a x value will going to be standard, which makes this whole expression turn into a 0. And for the last one, y is equal to 8 times x minus p squared plus q's graph. It is a transformation of y is equal to ax squared that added this to both of these two graphs. And that means we moved y is equal to x squared's graph to the x direction for a p times, and for a y direction for a q times. And we could have found a vertex through this form, and we called it a vertex form.